Well, first of all, thank you for this very, very lively discussion, and I'd like to introduce our next speaker, and he's going to talk to you about decentralized marketplaces for cloud resources and what the evolution is driving, in which direction. Gilles Fedak is the CEO and co-founder at iExec and INRIA research scientist, as well as Best Paper and PIFI Award Owner. Now, as a research scientist, he is working on efficient ways to collect and harness PC processing power. He has also produced pioneering software and algorithms in the fields of cloud computing and grid technology, and he has created iExec to deliver high-performance computing to distributed apps. So welcome, Gilles.
Hey, thank you for this very nice introduction. So this talk today, I'm going to present you for the first time the first decentralized marketplace for cloud resources. So obviously, this is not my work. This is real teamwork. We are now 20 people in Lyon, in France, working on that. Some of them are here. We are at booth number 5. We have Oleg, François, Jean-Charles, Agnès, Eduardo. So please visit the booth if you want to learn more about iExec. So what is iExec about? What we want to achieve is building the first decentralized marketplace for cloud computing. So what does it mean? The goal is to have this marketplace where everyone can monetize the computing resources you usually find in a cloud. Here I'm talking about servers, applications, and data sets. And we want, so you can think it as a sort of Airbnb for servers. But of course, without Airbnb. We're using the blockchain technology. So it's fully decentralized. It's about decentralization. And people who are customers and people who are providers can interact in a peer-to-peer way. We, iExec, we deploy all the technology to do that in a full trust, traceability, and in an open fashion. So when did we start it? We started actually this adventure about more than a decade ago. Most of us, we are former researchers in the area of distributed computing, cloud computing, high-performance computing. And during this past decade, we are working at CNRS and INRIA in France and in the Chinese Academy of Science in China. And we are working in this space. We developed many algorithms, many software that we are now using to build iExec. Actually, the project started really in April last year, so a little more than a year ago, when we issued the RSC token. I got funding for that. We did an ICO. So we emitted more than 80 million of these tokens. 6 months later, we released the first version of iExec, and this first version was solving a problem which is crucial in the area of blockchain. We are allowing, so we released the first software development kit that allows to do off-chain computation. So if you are familiar with blockchain technology, you know that developers, when they deploy their application on Ethereum, for instance, they face a strong limitation, which is the fact that the code that you execute on the Ethereum blockchain, you have access to very limited computing capacity. And so iExec was, I think it's one of the first practical solutions to do off-chain computing. So we use this SDK, we use the dApp Store, which is a curated list of decentralized applications that run on Ethereum and that run on iExec. And we started also what we call a dApp Challenge, which was a way to promote this solution to blockchain developers. But there was an issue. There was a very strong limitation with this first version. It's the fact that it was still centralized. So we allowed people to go from on-chain to off-chain, but when the application was executed off-chain, it was executed on our own servers. So it was centralized in somehow from the computation part. So today, we are announcing the version 2 of iExec, and version 2 is really decentralized. It means that now we are building a network of machine providers, of cloud providers, and developers can now execute their application in a fully decentralized way on a distributed infrastructure. And more than that, we are releasing a new marketplace, which we think, is really changing the way we do cloud computing now. I will introduce that immediately. So what are the markets we are looking at? With version 1, we were only able to address the market of the dApps, so those applications that run on the blockchain. Right now, and thanks to this new version, we can address all the applications that are running on the centralized cloud, but that are in need of, that requires huge computing power. And actually, there are many of them. You know, everything which is about artificial intelligence, simulations, finance, 3D rendering, etc., etc. There's an ever-growing need for computing resources. And those applications, those developers, those businesses, they're looking for a cheap way to execute their application. Think about, you know, AI. They have to train their neural network, and it's really costly. And so we read this dApp store, and if you look in this dApp store, we have now more than 50 applications. You can see a match between the market we're addressing and some of the applications that correspond to this market. So, for instance, we have the application called Blender. It's very famous, an open source application for computing 3D images. And I will talk about that later, and I will show you how we can execute Blender on iExec v2. So the thing that we are releasing today, and it's a real breakthrough in the IT industry, is the fact that we are doing a marketplace that allows to trade computing resources as a commodity. So I say it once again because I want you to remember that. Trading computing power as a commodity, you know, like the oil market. So why is it important? Today, if you are a developer and if your application runs on the centralized cloud, it works like this. You go to a specific provider, let's say Amazon Web Service. When you're on this provider, you have a whole bunch of instances. You select some of them. So an instance is like a machine, if you want, like a virtual machine. They have many different characteristics. The pricing depends on the machine, depends on the way you actually provision those machines, and also depends on the region. So that's very complex, and it's extremely difficult to compare the various offers coming from different cloud providers. So we're going to change that. And the way we are changing that is that now people will go to a single marketplace where all providers are going to compete. So to do that, we had to propose several innovations. And the first innovation is what we call paper task. So what does it mean? Paper task, it means that you don't rent a machine on which you're going to execute your application. You pay for the execution of a task. So now you don't care if this task has been executed on this provider or this one or this one or this one. You pay for the execution of a task. And this is totally new. Okay, well, it's not totally new because it's similar a little bit to the Amazon Lambda, if you know that. But what is new is this marketplace and the fact that you can trade computing power like a commodity. So how does it look like? So before, we're going to see a demo so that you can see how it works, you know, in a real case. But before that, I want to explain you the user interface so that you will be able to follow this demo. So if you're familiar with trading, maybe you already know this kind of interface. It's very similar to trading. But this is for trading computing power. This is not for trading your favorite tokens. Okay? So what you see, typically you see the price in RSC. So RSC is the token to buy the execution of an application. You see a work order where there are all the computing resources that are ready to be executed. You see the recent trades. You can see the trades that you pass, and you have a buy-sell window where you can buy some computing power or sell some computing power. So now let's see how it works. If you can please launch the video. There is a little movie. Please, can you launch the movie? Okay. So first, here what you see is the pool of cloud providers that are in the marketplace. So we are deployed on Kovan, which is a testnet for Ethereum application. Here what you see is the dApp store. So as I said, at the moment we have about 50 applications. We're going to use Blender, and here we're going to copy the address of Blender, and now we're going to the marketplace. So in the marketplace, you have to log in. So we have several categories that correspond to the envelope for the executions. We have the order book. We are going to pick one of the work order in the order book. This is the wallet, so you can verify that you can actually buy those computation. The recent trades correspond to all the trade that has been executed and also the computation that happened. And now we're going to buy some computing resources to execute the Blender application. So what you see here is some parameters that we fill for this particular application. So Blender, that's going to be, for instance, the image you want to compute. Now we buy the computing order. There is here an interaction with the blockchain. These are all actual transactions happening on the Ethereum blockchain. It's really decentralized. And you see that it gets updated. So the order book got, there is one order less in the order book. And you see recent trades. And if you click on recent trades, then you go on the iExec Explorer. So this is similar to Etherscan, if you want, but for iExec. And you can see the result of the computation. And if you click on it, you will see the result that happened, which is actually the image that has been just rendered. Okay, so to sum up, we selected an application, we went to the marketplace, we got an order to buy computing resources, and then we got the result. Okay, so of course here it's still testnet, but imagine that you can have as many cloud providers as you want, and they are all going to compete to have the best price at a given time. And this is really new, it didn't exist before. Okay. So as I mentioned, we have some worker pools in this marketplace. We have two kinds of worker pools. So what we call worker pools, it's the machine providers. So we have public worker pools. It's organized like miners, if you know mining. So usually when you're a miner, you're not a sole miner. Usually you join a mining pool to make sure that you have a chance to get a reward for your contribution. So here it's the same way. You join a worker pools to make sure that you would get some work to do. And it's up to the worker pool, to attract the computation and to be good at giving you some computation to do. And then we have what we call private worker pools. So these are well-identified cloud providers, so if you want more in B2B fashion. At the moment, we have 4 companies joining the worker pool. These are IT companies, these are startups working the green IT field. So they have new disruptive technology to create green data centers. It's very interesting. I really encourage you to dig at those at Carnot, Decentralized, Steamergy, and Cloud and Heat. I love what they're doing. It's really amazing. And we're also going to have more traditional cloud provider. And today, I'm really happy to announce that we have a partnership with TF Cloud, which is one of the main Chinese cloud providers, something really big. They have been the first one to introduce OpenStack in China, and they are very legit. It's a big company. So if there is an interface for worker pools. If you go in this interface, you can actually see what happened. So there is nothing. So here it's the traditional dashboard you have when you are an administrator for a HPC machine or cloud or whatever. And this is very traditional, but we like it. There's the list of machines, what they did, number of tasks executed, and so forth. And in addition, what we do is that we also give some indication about the RSC that went for payment. And that's important for public worker pool, for instance. Today, we are also releasing the first version of the proof of contribution protocol. So it's something really important because this is the actual technology that enabled decentralization. So what is proof of contribution? What is this protocol? What is this algorithm? The issue is you are provisioning a machine on the internet, and maybe you don't trust the machine that has been provisioned. So the question is, how can I guarantee, as a developer, that the machine did what I asked for and what I paid for? So this is what proof of contribution is about. So I can't go in details. It's quite not complex, but there's a lot of mechanisms involved. We do result certification by majority voting, so that's a traditional way of doing that. Plus, we do staking, which means that each actor has to stake some RSC before doing the computation. And we're also using reputation. So the algorithm is all open source. It's already deployed on Ethereum. It's on GitHub, so you can, if you're interested, I encourage you to check that also. OK, so what's next? Well, I say it once again because I love that. We allow to trade computing power as a commodity, like the oil market. That's for me, it's totally amazing. The agenda that is coming is quite exciting too. So this is now available on testnet, on the Covan testnet. So you can play with the marketplace. You can do that right now. GitHub is open as well. We're going to move that on mainnet as soon as we feel confident to do so. So far, so good, but we really want to make sure that there's no friction about that. So it should happen, hopefully, in the coming weeks. As soon as it's on mainnet, we're going to do what we call the worker drop. So worker drop is like an airdrop, but for workers. So we are going to create a worker pool for like 48 hours, something like that. We're going to launch some tasks. And anyone who connects as a worker to the worker pool, to this public worker pool, is going to have some free RSC. And for us, it's a very good use case to test and make sure that everything works. The public worker pools are scheduled probably for September, October, but we have no timeline right now. There are some additional stuff to do. Not with the POCO. I think POCO is ready, but most probably in the way people can interact with. And first, we want to make sure that people actually have work to execute, unless that is going to be it's not going to be a success. We are at the moment working with Intel on a new technology. I mean, they have produced a technology which is called IntelliJ, which is enclave, something really promising. And we have first proof of concept. We expect that by the end of this, maybe it's October, we are going to have the first inclusion of this the first product that uses this technology in iExec. It's really important because it allows for privacy preserving. So you can do a computation on a remote machine that you don't trust, and your data are going to be kept encrypted even though you don't trust this machine. It just didn't exist before. That's really something exciting. OK, we'll be at DEF CON, of course, in Prague, and I encourage you to be there also. We are certainly going to run a workshop. It's a full day for developers, for iExec lovers. And in 1 year from now, we're going to release V3. V3 has some very advanced features, some that are very new, like dataset monetization. So dataset monetization is, imagine your data, your personal data, like the one you have with Facebook. Those data are yours, and each time a company wants to use it to sell those, the analytics of this data, you're going to get some rewards. And we are part of the Ethereum Enterprise Alliance, and we are going to cooperate more and more with them to make sure that the solution we propose can actually be used by traditional businesses. OK, thank you very much. And
would you like to take maybe 2 questions or 1 question?
I can take some questions if you want.
Maybe start with 1 question. Is there anyone who wants to ask a question? I think everybody's tired. Oh.
There is one.
Just curious, since buying the computing power is through your own currency, RLC, right? Mm-hmm. if you've thought about the implication for the end users in terms of the volatility of the total cost in the end. In other words, in my business process, if I want to use certain amount of computing power, I need to sort of budget for it. And if the RLC is fluctuating, how can I sort of, I don't know if you've kind of thought about that aspect, if that inhibits adoption, perhaps.
Yeah, that's a good question. I think it's a question, so the question is about the volatility of RLC, and if I'm a business, how can I, deal with that? I think it's not specific to RLC. It's for every, business that has been created using this economic model based on a token. I think that we are more and more we are seeing some solutions that are emerging and that allow us to deal with that. So we can easily imagine a solution where there is a price given in a token that represents a euro or a dollar, and then going to a decentralized marketplace, changing in RLC, and then use the RLC within the network. In the network, RLC is central, because this is the one we stake for the proof of contribution, for the consensus algorithm. Okay? So at the end of the day, there will be some RLC exchange between the providers and the customers. Okay? But for a business, like you said, most probably they don't want to see the RLC. What they want to see is a bill in euro or in US dollar. So I think that once the ecosystem is mature enough, most probably we're going to, for instance, we have a partnership with Request, and Request is a project that offers some sort of bills, on top of a transaction. So most probably at the end of the day, I mean, that's the goal of the enterprise-ready version that we're going to release in 1 year. It's to solve all these issues so that at the end you can have maybe your bill labeled in euro, even though under the hood it's many different tokens, not necessarily only RLC. It could be RLC for computation, plus another one for storage, plus another one for another service, etc., etc. But that's the way we see the future for this decentralized economy.
I think we need to close because we're running over time. Thank you very much. Merci.